Yeah, we will prefer to the higher end. So close to is good. Yeah.
So if it starts dropping lower, then you want to have more water, right?
Correct. Yeah.
So if it's much higher than that, then you're adding maybe too much water?
This is we're talking about under steady state condition. Okay. From the very beginning, you will start with the neutral, like 7, something like that. If after two months, when the bugs population fully developed, you still get 6 or 7, that is too much. Then you need to reduce the water usage a little bit, just step by step. It will be getting into steady very quick. So I think you guys already have pretty good idea on the system number 1, which is developed on the same design, similar design, same concept, everything.
On the other system, in previous O&M, it was 2 to 3, and
The other one is 2 to 3.
yeah, that's why I was a little curious.
Oh.
It seemed 1 and 2 is
Okay,
kind of
then
low.
you can go down to 1 to 2. Yeah.
Okay, so
But ours is typically more like 4.
Did you check it today? The biofilter? What was the pH today?
It was higher than that.
Yeah, is it usually 6?
So we'll go over that tomorrow.
But we
Okay.
were also told with the last sample that we
Too much water.
used too much water. Yeah.
Okay, if that is the case, you probably add a little bit too much in the high sand. You add too much water will not hurt the system, only waste some water, that's all. Yeah, you don't hurt the system. But you have too less water, you will hurt it. Okay? If you too less water, either the acidity goes too acidic or the media can go dry. That is no good. If you add a little bit too much water to get the pH a little bit higher, that's no problem. That does not hurt the system at all. Yeah, if we want to error on the high end.
Can I have a question?
Yeah.
On the nutrient pumps, you said there's 2. Is that for each biofilter, or is that
Yes.
one pump can do both?
One for each.
One for each.
Yeah, one each. Each chamber is separately controlled. Okay. Now we are in the water panel, irrigation panel. What you have in the irrigation panel is a big stainless steel box again. Inside of this, you have 4 solenoid valves. Okay. For each channel, you have 2 solenoid valves, one for the lower section, so the lower irrigation for this one. Another solenoid valve is the upper irrigation. So you get 2 chambers, you have 4 valves, all right? And also you have two nutrient pumps in here, like the gentleman just asked, okay? This is one pump, this is the other, all right? Then your water coming into here, and we have a shut-off valve in here. Okay, then you go through a regulator to set the water pressure. What we want to see is you set the water pressure. When the water is not flowing, you get about 60 pounds. Anything between 60 pounds, 70 pounds, that's fine. It can change a little bit. Right now, the settings are good. It's okay. When the water is flowing, the pressure will decrease a little bit. Okay, what we read for the past 2 days is about 50. That's fine. That's good. Okay, here is the water flow meter in here. Then when the cycle is on, you can see the flow meter is, you can read the float, okay, from the top. You get your GPM flow, all right? Then these 2 small stainless steel boxes, just the junction box to connect the electricity to the solenoid valves and the pumps. Okay, the pump will suck the nutrient from the tank. On the side, we just see the other picture, the black drum. Suck the nutrient from there and deliver it to this T, get into the top irrigation. Now then be added to the system. Okay, here's the view of the inside of the biofilter. You don't see the spray nozzle. This picture was taken before the upper irrigation nozzles installed. So you can see the media is packed up to this level. This is organic media. This is your sump, the irrigation sump. And what you have is 2 recirculation pumps in here. And one is on duty, one is standby. And this, again, we supply the pump. We did not design the whole thing. So I think the concept is you use this pump and pump the water through this, go here, go up to this humidification chamber. We have 4 nozzles on each chamber. So then spray water into there. Then the water come from that chamber, come back to this sump through this pipe. Looks like this is a 6-inch pipe. Let's get back to here. And when the water goes up to a certain level, you have an overflow pipe in here. This overflow pipe will take the water from this chamber, from this sump to the waste drain sump to the other one. Okay, then you add, periodically you need to add fresh water to this sump through this pipe. This is a pipe, show up in here. So this is controlled by 2 level switches. I don't see the level switch in this picture. I don't know where. It's hanging in there somewhere. Yeah, it's on the top probably. Yeah. Yeah, we don't see it in this picture. You have 2 level switches there. Here's the key parameters to have an eye on. Or you're doing the log. We have the log sheet in the O&M manual called the Appendix C. We will see that in a few minutes. This is something you need to, in the operation, you need to keep an eye on. Hydrogen sulfide concentration is always we need to know because this is the food for the bacteria to grow. Airflow rate, you don't need to change that, check that too much because when it's set, I think it's pretty stable unless you change your operation conditions. And temperature, and I don't know if you probably don't have much control. For this one, it's pretty good because most air is sucking from inside of a building. So it's not too cold. And the irrigation water flow through the flow meters we just saw, and the nutrient supply. That is actually, in a day-to-day basis, this is the only thing the operator needs to do. And they just pay attention to the nutrient tank, don't let it to dry. Other stuff is all automatic control. All the nutrient tank need to be a man refill. That's all. All right. Then I'm come to the operational log sheet and the process setting history chart. This is in the Appendix C of the O&M manual. This is the log sheet. Okay. If you see the frequency of measurement is pretty low. I'm talking about when the system goes to steady state condition, which is maybe 4 to 6 weeks later. But within the startup period of the first 4 to 6 weeks, the bugs is growing. You probably need a little bit more frequent measurement just to make sure everything is good. And after that, then you do this, follow this. This is our recommendation. Okay, this is our recommendation. You do this monthly. Some of the stuff is go monthly, some is go weekly, some go quarterly. So I just can read this. I give you a reading for what we got yesterday afternoon. So yesterday afternoon, we rebalanced the airflow to the 2 chambers, and right now it can be fluctuating because you know, the air measurement point is not a perfect place. So that is only available. Generally, you measure airflow, you need a certain length of street pipe. So we don't have that in here. So, but give you a good indication though. We balanced up at 12,250 CFM each. So add together, it's about 25,000, right? The temperature we measured is 68. That is in the range. We did not measure humidity. The biofilter inlet hydrogen sulfide concentration we measured quite a few times. Okay, since Tuesday, we always get 0. So we don't read anything from there. So no hydrogen sulfide. Then you have to measure the outlet. Of course, we even measured the outlet, it's 0. If inlet is 0, outlet should be 0 anyway. And the biofilter air temperature we measured yesterday afternoon is 71, so a little bit higher than the inlet because the whole thing is covered. You collect the water, you collect the warm heat from the sun, so it's a little bit higher. Yeah, please.
If the temperature you just said is on 60 to 80 is good, what would be a concern for you if the temperature dropped below a certain point for the bug activity or whatever?
It will, at the lower condition, like see, we want to see the temperature range between 55 to 100 F. Okay, generally we don't want it to be beyond 100 F. If it's beyond 100 F, some bugs will be, sensitive bugs will be killed. But it's lower temperature only slow it down, does not kill anything. They will be there. You think about the refrigerator, okay, because this is a bacteria similar to that. If you put something in the refrigerator, the bacteria will stop to grow, no function. So your food will be not bad for quite a few days. If you put it in a normal room temperature, it's getting deteriorated very fast. Same thing, the bacteria, different bacteria grow in there. It's just working in a different way. Okay, one thing I need to mention here is, you see the pH we mentioned here is 1 to 2. One thing I want to mention here is for the drain water sample, a lot of people just forget it. They don't do it. And in most of the cases, you install the biofilter, and a few weeks it's kick on, everything's good. People no complain, people just forget it. They never do anything. But I still suggest you to do this at least monthly or quarterly. Or if you see the biofilter, I don't think it's work proper. And then you take a sample for that. That sample, those stuff need to be analyzed. Generally, we want to see ammonium nitrogen, nitrate nitrogen, should be, and phosphorus should be greater than 5 milligrams per liter. So if you take a sample, you analyze this. I think it is convenient for you. You have a lab, do you?
Is it what are you sampling, the waste?
The drain water. The drainage
That's
water.
going back to the research?
Drainage water is come back from biofilter bottom to the drain well. You have a well.
The wastewater well,
Yeah.
the 2 wastewater pumps, not the
Yeah.
recirculation.
Yeah, you're right.
It's a research check.
Yeah, you collect
So
sample
we get
there.
the discharge, yeah, we can get down in there. We can look
So you
at,
can check to see.
Yeah. Periodically do analysis on this. It can be save you a lot of problems, because if you see, okay, my nitrogen and phosphorus is measurable. That means you are not nutrient limited. If you get too high, for example, I say, okay, if you can detect 5 milligrams per liter, that's enough. If you detect, you get there for 50 or something, that means you don't have much contaminant in there, and you add too much nutrient. Although the nutrient is not a big deal for you, like I said, every batch you need 20 pounds. Okay, 20 pounds in there lasts you for 4 weeks. So I will see 10. We bought that starting up nutrient for you. 10 pounds is $17. So $1.70 per pound. Yeah.
What is the nutrient? Is that readily available?
It is really readily available. What we use, you can use any nutrient contain nitrogen and phosphorus, but we prefer to use a nutrient also contains some micronutrients in there. It's in the manual in detail. I also give a label to a gentleman attended morning session. He has we use a Miracle Grow. Yeah, you can use Miracle Grow. It's readily available from Home Depot, Lowe's, whoever carry it. If you buy a large amount, probably you get a discount. What we got is $1.70 per pound. Okay, if you think about $1.70 per pound, you get 20 pounds. It's $34 per month. Yeah, that's less than about $1 a day for such a big system. So you think about that. It's not a big deal, I think. Okay, this is the history chart for setting up the timers. Okay, like I said, you have chamber 1, 2. This one is your recycle timer. Okay, you have this recycle timer is different model from the other one. This is called the GT3W whatever you call this. This one have two timers, T1 and T2. And the T1 we're setting at 19 minutes. T2 right now is 1 minute. The 1 and 2 together, we call that cycle. Put these two together, it's a cycle. That means every 20 minutes, the cycle starts over again. Okay? Once the cycle starts, what you have is on this consequence. Okay? You get chamber number 1 lower irrigation on for 30 seconds. When that is done, then the upper irrigation and the nutrient pump goes on the same time. Okay? But for a different duration. The upper irrigation water will on for 10 seconds, and the nutrient pump will go for 36 seconds. Don't worry about that. The nutrient pump goes longer than this because nutrient pump is very slow. Okay, you get nutrient added into there. Even the upper irrigation is stopped, the nutrient will stay in the pipe. The next cycle will push it through and spray on the top. So when the chamber 1 is done, which is the yellow color thing, then this chamber 2 will start. It's exactly the same settings for the timer. Each timer is identified by its name. So like this one is TR127, TR133. It's labeled in the control panel. You can see it. Okay. This one, if you don't change your operation condition, probably you don't need to change it anyways. You already set it this way. If you do need to change it, for example, if you take a sample, you determine, hey, I add too much nutrient in here. Then you can reduce the nutrient pump from 36 to whatever the number you want. Okay, you run for a few months, a few weeks, you take another sample. You know, all the settings is based on the design condition supplied to us, which is 5 to 20 ppm of hydrogen sulfide and other stuff. If you are, like right now, the concentration is undetectable, but we still need to supply some minimum nutrient to it, you know, for the bugs to grow. Otherwise, all rock. There's no food for the bugs to grow. So that's our suggestion. Yes?
Can you explain the difference between the nutrient pumps in this unit compared to the old unit? What kind of pumps are the new ones, and then?
I don't know what is in there for that one. I was not involved in that particular job. Those are that was dosatron. Oh, that is different. Okay, that dosatron does not need the electricity. That is worked on a vacuum. Like you add water to it, you create like a Venturi type of thing. You create a vacuum and suck it through it. They have a setting lock in there. So that's a different. I'm sorry, I did not look at that. Those pump are peristaltic pump. This need a timer to control. We changed that to this because we have some problems with that kind of pump. Sometimes the settings are not accurate. Sometimes you get clogging. And we changed that. That one was built in 2006, is that right?
Yes.
Yeah, I think it's 2006. Yeah, we changed that nutrient supply design from 2008, I think. So this is more reliable, this pump. Yeah. And I want to give you a little bit of information about the Envirgen's odor control product line. So basically, for the vapor and odor control, we offer modular biofilters and built-in-place biofilters. What you have is, we call that built-in-place. Okay, it's concrete, built-in-place. And also we have bio-trickling filters. Some people call that bio-scrubbers. Okay, it will not take that long, just 1 to 2 minutes, very quick. Okay, this is H120 series, small. You can put one single, dual, triple together. This is good for pump stations. If you have a spot and the pump station is a small, always get odor complaints in there, probably emit from there. And you can put one of these small things in there. We get a lot of this small thing installed in the sauce, like in Florida, Texas. And we have triple. Then we have a larger one called the P600. Okay, this is a P600, a big box, bigger fiberglass box. And you can single, you can kind of dual, which is 2. You get triple, 3 together. And you can get whatever the number you want. This is 6. When this goes too many, anything beyond 3 is no longer economical. Okay, if you need 3 or more, the better go to a built-in place. That's cheaper than go to the modular ones. Then you have this one, probably everybody familiarized. Yeah, this is your old biofilter, older one.